Hi guys, so today I'll be explaining the chemistry week 3 AMS quiz of term 2. Okay, what is the oxidation number of an atom? This one you have to memorize it, okay? So the oxidation number is a Fisher's charge that is assigned to every atom according to certain rules. In which of the following molecules oxygen has an oxidation number of -1? Okay, so we know oxygen, which is O, always has a oxidation number of -2, except when it's with fluorine, I think, or fluorine. It would be +2, and if it was peroxides, it would be -1. And the peroxide is basically any element from group 1, which is like the first row on the periodic table, and then you add a 2 and then O2. Like for example, K, because K is in the first group, so K2O2. Okay, so the oxidation number of O in this case would be -1. So let's check the options. So it would be this one and this one. Okay, it's not O2 because here that it's in the elementary state, so its oxidation number would be 0, and it can't be this one because it's not it's not a peroxide. Okay, and it's not H2O because again it's not a peroxide, and these two are peroxides, so that's why they're the answer. Okay, which of the following are two half reactions of electrolysis of molten NaC? Okay, so look, we have two types of electrolysis, okay? We have molten and aqueous. So for molten, it would be something like this. Let's say like this is our beaker. Oh, wait, let's try again. This is our beaker, and then we have this thing, and then this, okay? So we know the longer line is the positive one. So this would be positive and this would be negative because this is a battery. And the positive side is called an anode, and the negative side is called the cathode. Okay, and we're talking about molten right now. So molten electrolysis. Okay, so again, this is the anode, the positive side is the anode, the negative side is the cathode, and the anode always has the non-metal, and the cathode always has the metal. And at the anode, we always have oxidation, and at the cathode, we always have reduction. Okay? So, if you forgot what that means, oxidation is the loss of electrons, so the electrons would be in the reactants, and reduction is the gain of electrons, so electrons would be in the products. Oh, wait, no. Okay, in case you forgot, oxidation is the loss of electrons, so electrons be in the products, and reduction is the gain of electrons, so electrons be in the reactants, okay? So let's check the options. Or let's talk about NaCl first. We know Na is the metal, and Cl is the non-metal. Metal. So Na would be at the cathode, and Cl would be at the anode, because again, the non-metal is at the anode and the metal is at the cathode, and we would have oxidation with, oxidation with Cl, so electrons would be in the products, and we would have reduction with Na, so electrons would be in the reactants. So at the cathode, we have the metal, which would be Na, so this one, and then at the anode, we would have the non-metal, which is Cl, so this one, okay? And again, because Cl is the non-metal, we would have reduction, so because it's the non-metal, we're gonna have oxidation, so the electrons would be in the products, and because Na is the metal, we would have reduction, so the electrons would be in the reactants. Okay? An aqueous solution of HCl is added to lumps of CaCO3. So again, we have CaCO3 and HCl, which is an acid. which one of these react with an acid? CO3. And we know CO3 plus HCl, acid, gives CO2, which is bubbles of gas, so formation of bubbles. That would be the observation, and the net ionic equation would be H2O and CO2. Because remember, metal carbonate plus acid gives H2O and salt and CO2. Okay, the oxidation number of aluminium in AlNO3 is... Okay, so since here we have two unknowns, which is Al and N, because we have to know the oxidation number of N and O to find Al, we're gonna have to separate these two. Okay, so we know it would be Al3 plus and NO3 minus. Okay, and since the oxidation number would be equal to the charge, Al would be plus 3. The oxidation number of Al would be plus 3. Okay, and in the second one, since it's in the elemental state, its oxidation number would be 0. Okay, so here you have to find the oxidation number of hydrogen. We know that hydrogen is always plus 1, except when it's with a metal hydride. Metal hydride, which from its name, just any metal and hydrogen. So like for example, NaH. The oxidation number of H in this case would be minus 1. Okay? So again, H is always plus 1 except when it's in a metal hydride. So in the first case, the oxidation number of hydrogen would be plus 1. Second case, again plus 1. Third case, since it's in the elemental state, it would be 0. Okay, in metal hydride, hydrogen has an oxidation number of -1. An example of metal hydride is CaH. By the way, if you don't know any metals, if you don't have them memorized, it's just in the periodic table. The metals are on the left side, on your on your left-hand side, and the non-metals are on your right-hand side. Okay? So here we'd have the metals, and here non-metals. Just in case you don't know. Okay, here you have to find the oxidation number. We know in oxygen it's always -1, -2, except when it's with, let me see here. O is always -2, except when it's with F, where it would be +2, and if it's with peroxide, it would be -1. And again, peroxide is just any element from group 1, and then you add a 2, and then O2. So here we don't have, it's not an element from, so it's not a peroxide and doesn't have F. So oxidation number of O is -2. And here, since we need to find N, we're just going to put X for N, since we're finding it. And since we know the sum is equal to 0, we're going to add, so again, X plus the oxidation number of O, so -2, and then we're going to multiply by the 2. So 2 times -2 is equal to 0. So it's going to be X minus 4 is equal to 0. Oxidation number of X of N is equal to plus 4. So plus 4. Let me explain again, okay? Again, here we don't have F, and it's not a peroxide. So the oxidation number of O is -2. And since we need to find N, we're going to put X for that. And then we're going to add that to O, which is -2 times 2, because we have 2 O's. Okay, we're only doing that to solve. We won't put that as the answer. The oxidation number of O isn't -4. We're only putting that while we're solving, okay? So 2 times -2 is equal to 0. And then X minus 4 is equal to 0. And then the oxidation number of N is equal to plus 4. So plus 4 and minus 2. Okay, and then here, oxidation number of hydrogen is always +1, except when it's with metal hydrides, which here it isn't. and the oxidation number of Cl is always -1 except when it's with oxygen or fluoride or fluorine or F, and here it's with oxygen, so it's not -1, so we're gonna have to find that by solving. And always -2 except when it's with F or peroxides, which here it isn't, so it's -2. And now we're gonna have to solve. So 1 plus x, again 1 from the H, and then x for Cl, and then plus 4 times -2, because we have 4 O's, is equal to 0. So x minus 7 is equal to 0. So the oxidation number of Cl is equal to plus 7. Let me explain it again. Okay, hydrogen's oxidation number is always +1 except when it's with metal hydride, which here it isn't. And again, metal hydride, just any metal and hydrogen. So here, since it isn't with a metal hydride, its oxidation number is +1. So now we're gonna go to Cl. Cl's oxidation number is always -1 except when it's with oxygen or F, which here it's with oxygen, so it's not -1. We're gonna have to solve for it. And oxygen is always -2 except when it's with F or peroxides, which here it isn't, so it's -2. Now, since we have to find Cl, we're gonna do 1, which is the oxidation number of H, plus x, since we're finding Cl, plus 4 times -2, since we have 4 O's, is equal to 0. Now, we're gonna get x to be equal to plus 7, which would be the oxidation number of Cl. So +1 plus 7 and -2. And last one, again, oxygen is always -2 except when it's with F or peroxide, which here it isn't. So oxygen is -2, and yes, we don't know M, we don't have any rules for it, so we have to solve for it. So x plus 4 times -2, since we have 4 O's, is equal to -1, which is the charge of the compound, or sorry, ion, okay? So x minus 8 is equal to -1, x is equal to plus 7, so plus 7. And let me explain it again. Mn, we don't have any rule for it, so we're gonna have to find it by solving. Oxygen is always -2 except when it's with F or peroxides, which here it isn't, so the oxidation number of O is -2. And now, since we have to find Mn, we're gonna do x plus 4 times -2, because we have 4 O's, is equal to -1, which is the charge of the ion. And now, when we solve, we're gonna get x to be equal to plus 7, which is the answer. So plus 7 and -2. Okay, here you have to find redox reactions. Now, look, my teacher, she told me, she said, normally redox reactions, there's 2 types. For what we need to know now. There's metal plus oxygen to give metal oxide, or metal plus acid to give salt plus hydrogen. Okay? These 2 are normally redox reactions. Okay? But it's better if you find the oxidation number of each element and then check if they increase and decrease and go through oxidation and reduction. But if you don't have enough time, just memorize these 2, and if you find them in the options, just select them as redox reactions, okay? So here, we're gonna have to find if we have metal plus oxygen to give metal oxide, or metal plus acid to give salt and hydrogen. This one isn't, so it's not a redox. This one also isn't. This one is metal plus oxygen to give metal oxide, so it's a redox. And this one is metal plus acid to give salt and hydrogen, so it's a redox. Okay? So non-redox, redox. Okay, here the oxidation numbers are equal to the charge. So here, since it's Br minus, so it's -1. O2 minus, O2 minus, so -2. Ca2 plus, so +2. Na plus, so +1. and the sum of all oxidation numbers here is equal to 0, because the sum of all oxidation numbers in a molecule is 0, except when it's a complex, when it's a simple ion, so it's going to be equal to the charge. Here we have to check the oxidation number of each element and check which one increased, because we have to check the oxidized one. Okay, so oxygen is always -2, so -2. And here, since we have to find Cr, we're going to do 2x minus 14 is equal to -2. We got 14 because 7 times -2, and it's 2x because we have 2 Crs, and it's equal to -2 because that's the charge. And if we solve, we're going to get 2x is equal to 10. Or no, 2x is equal to 12, so x is equal to 6. So Cr is +6, and then K, since it's in the elementary state, it's 0, and hydrogen is always +1. And then here Cr, it's already there, so 3 plus 3. And here they already told us it's +1, and here +1 minus 2. Okay, so which element's oxidation number increased? Cr went from 6 to 3, so this one decreased. This oxygen went from -2 to -2, so it stayed the same. K went from 0 to +1, so that's oxidized species. And H stayed the same, so it's not the answer. So the answer is K. Since its oxidation number went from 0 to +1, it increased. Or no, it's K, because in the reactant it's K. This one you have to memorize. The process of forcing an electric current into a system of chemicals as a result of which chemical reactions that normally do not proceed is called electrolysis. Okay, this is all material. So we choose the ions that form a white precipitate upon the addition of KSO4. It's gonna be Ca and Ba. Yeah, because SO4 isn't soluble in Ca, Ba, and Pb. So it's gonna form a precipitate with Ca, Ba, and Pb, but there's no Pb. So it's just Ca and Ba. And here, white precipitate, when you, with NaCl, when you add AgNO3, because Cl and AgNO3 form a white precipitate, so Ag. And then last one, KBr, you get a creamy precipitate, so again AgNO3, so Ag. Whichever given ions release a gas that turns lime water milky. Whenever you see lime water milky, it's carbon dioxide. And what reaction releases carbon dioxide? CO3 2- and acid. So carbonate. Which given ions release pungent gas that turns red litmus paper blue upon reacting with the base. Whenever it's a pungent smelling gas without aluminium powder, then it's NH4. Okay, because NH4 and NO3 minus both release NH3, which is the pungent smelling gas that turns red litmus paper blue. But the difference is that here we add Al, which is aluminium powder, which is the catalyst. Okay, so that's the main difference between them. So here, since you didn't add aluminium powder, it's going to be ammonium, and here, since you added aluminium powder, it's going to be nitrate. Okay, a student is asked to find the OH minus of hydrochloric acid in aqueous solution, HCl, whose pH is 5.36 at 25 degrees Celsius. So we're going to use Kw, which is again equal to concentration of OH minus times the concentration of H plus, and Kw is equal to 10 to the power of -14. And if we need to find the concentration of H, and since they gave us the pH, we're going to use the formula negative log of H plus is equal to the pH. So negative log H plus is equal to 5.36. And if you have a calculator, you can solve for x. You can just solve for it now. But if you don't, you multiply both sides by negative, so you get log H plus is equal to negative 5.36, and then you do 10 to the power of negative 5.36. Okay, and then you're gonna get the answer. So 0.37 times 10 to the power of negative 6. That's concentration of H plus. Okay, now we need to find concentration of OH minus. So the KW formula, so 10 to the power of negative 14 is equal to 4.37 times 10 to the power of negative 6 times concentration of OH minus. So we're gonna put that to the other side, and then you're gonna get 2.29 times 10 to the power of negative 9. That's the answer. Okay? So 2.29 times 10 to the power of negative 9. Okay, I'll just explain again. Okay? So students is asked to find the concentration of OH minus of hydrochloric acid aqueous solution HCl whose pH is 5.36. So we're gonna use the KW formula. It's equal to OH minus times H plus, and we're also gonna use negative log of H plus is equal to the pH. So first we use this formula since we only have the pH. So negative log of H plus is equal to 5.36, and if you don't have a calculator that solves for x, you're gonna multiply both sides by negative to get log of H plus is equal to negative 5.36, and then you're gonna do 10 to the power of negative 5.36, and then you get 4.365 times 10 to the power of negative 6. Okay, and then since now we have the H plus, we're gonna use the KW formula. So 10 to the power of negative 14 is equal to OH minus times 4.36 times 10 to the power of 65 times 10 to the power of negative 6. So you put that to the other side, you get OH minus is equal to 2.29 times 10 to the power of negative 9. Okay? Here it's acid or base or neutral or amphoteric. Now acid is just any non-metal and oxygen. Base is any metal and oxygen. And neutral is just N2O or CO or H2O or NO. And amphoteric is ZNO, Al2O3, and PbO. PbO. Okay? Acid reacts with base, base reacts with acid, neutral reacts with none, amphoteric reacts with both. Okay? So Mg is metal, metal plus oxygen, basic. This one's acid, since non-metal and oxygen. This one's metal plus oxygen, so basic. N2O neutral. ZNO is amphoteric. S is non-metal, so acidic. Al2O3 is amphoteric, and Ca is metal, so metal plus oxygen is basic. Okay, student wants to find the concentration of OH plus and OH minus in a sample of 0.4 molarity of a strong acid H2A in aqueous solution at 298 Kelvin. So here they gave us a concentration of H, but here since we have two H's, we're gonna multiply it by 2, so 2 times 0.4. So the concentration of H plus in H2A is 0.8, so 8.0 times 10 to the power of -1. And to find OH minus, we're going to use the KW formula, so 10 to the power of -14 is equal to 0.8 times concentration of OH minus. Put this to the other side, you get 1.25 times 10 to the power of -14. That's the concentration of OH minus. Okay? So 1.25 times 10 to the power of -14. Okay? Bismillah. Oh guys, I forgot to solve this question. The last part. So, which of the given ions release a gas with a choking odor upon addition of an acid? The only choking gas is SO2, which is released by SO3 2 minus and acid. So the answer is SO3, which is sulfite. Okay?